Hello, we are Team 7, proposing the topic Category-Infused Relation-Aware Collaborative Learning for Aspect-Based Sentiment Analysis. We will proceed with the presentation in the order of the overview. We are going to talk about the ABSA system that extracts a pair of expect and sentiments from the sentence. Most existing ABSA systems had the limitation of not considering the relationship between elements or not extracting category elements. However, extracting categories can help analyze the ABSA task in situations where the aspect is ambiguous or absent. So we propose the CRECL model, which is category-infused relation-aware collaborative learning method, adaptive to ABSA to improve the overall performance of the review analysis. To begin with, I would like to show you some examples of online reviews, which I'm pretty sure that everyone in this class has encountered with. There are hundreds and even thousands of reviews on the internet for each product, which act as a precious information both for customer and vendors. Then the question researchers started to think of is, what would be the most practical way in analyzing those reviews among existing NLP techniques? We found the answers to this question in aspect-based sentiment analysis called ABSA. ABSA system is a text analysis technique that categorizes data by aspect and identifies the sentiment attributed to each one. When we use ABSA system, just like the example below, we can extract aspects from a sentence and identify sentiment attributed to each aspect. That is, the existing reviews are summarized as the aspect, category, opinion, and sentiment as such. This provides a better summary of the reviews, allowing both vendors and customers to understand mass review data. That is why we chose the paper Relation-Aware Collaborative Learning for Unified Aspect-Based Sentiment Analysis. The model is divided into two steps, multitask learning and relation propagation. At the first step, multitask learning adopts shared private three subtasks, which are aspect extraction, opinion extraction, and sentiment classification. These tasks jointly learn the each level shared features. After training the features, the relation information should be propagated to another layer. By the multi-stack layer, it performs collaborative learning in different semantic levels. But there is limitation in paper approach that category term might not be extracted. Suppose a review, everything they served was very disappointed. Previous RECL extract everything as an aspect, disappointed as an opinion, and negative as the sentiment, but you can see that everything is not clearly defined. On the other hand, when we infuse category extraction, category term food quality can be extracted, which better represents the information customer really intended. Also, one aspect can have several opinions. Let's see the example of pasta was delicious, but it didn't come out pretty. Previous RECL extracts the relation pasta delicious and pasta not pretty, but it's not enough to represent the customer's intention. But if we infuse category extraction, food quality and food plating can be extracted additively. This provides better analysis of the reviews.
So we proposed a new relation-aware collaborative learning and paraphrasing method that infused category into ABSA task. This is the architecture of our new model, CRECL. We basically follow the initial architecture proposed by the RECL paper and add category extraction inside its layers. As you can see, we also define new relation between its terms. Through the adding category-related term in the shared feature of its layer, we target to improve the accuracy of the whole ABSA test. This gives a more detailed view of its layers. The previous approach defined shared feature and used the shared feature when predicting as term of ABSA test. We add category extraction inside the process to better improve the accuracy of the model. There was limitation in using the original dataset for our new model since there is no category annotations. Therefore, we look at two datasets, including category among the dataset used by other ABSA paper. First, we look at laptop ACOS and restaurant ACOS dataset, which involved all four terms of ABSA. However, what we noticed was that the labeling was often inaccurate. For instance, for the sentence "What a great place" was labeled as the aspect term, and "a great" was labeled as the opinion term. This labeling is not concise enough, and hence we thought it would not be better possible options. Next, we look into last 15 and last 16 dataset used in the code paper. Annotation here was very accurate and concise, and hence we decided to use data from code instead of ACOS. To apply last 15 and last 16 to our CRSA model, we have to change the format of the dataset as follows. This is the example of how we change the format. Instead of presenting the terms in one single list, we parse the data separately into aspect, category, opinion, and sentiment terms. We work to solve the problem of the initial RACL dataset. First, the initial dataset showed limitation when there were two or more sentiments related to one aspect term. For instance, for the sentence, "The food was nice but cold," only the first sentiment related to the aspect term was annotated. We solved this problem by adding the sentiments on top of the opinion term when there is a conflict. Another problem arose when there is an implicit aspect. Initially, sentiment for an implicit aspect situation was annotated at the end of the sentence as shown in the example. This is very inaccurate as it is not guaranteed that the last word gets related to sentiment itself. We solve this problem by adding the sentiment on top of the opinion term again when there is an implicit aspect problem. The number of the final processed data is shown in the table. Here, ACOS quadruple refers to a group of aspect, category, opinion, and sentiment, and as one sentence can include two or more quadruple, its number is higher than the number of sentences.
All right, next we'll move on to the experiments part of our presentation. This shows one of the examples of our experimental results. For the given sentence, previous RACL model only provides limited amount of information that eggplant from the restaurant is bad. On the other hand, our CRACL model shows that the review talks about prices, quality, and service of the restaurant and contains much referral information. This example proves the significance and importance of our model. We then calculated the F1 score of each element and compared it to the previous RACL model. Unfortunately, we found out that the addition of category has minimal effect in the F1 score of each element. You can see that the previous RACL model even had slightly higher F1 score for some of the tasks. Still, we can see that the model performs much better than the model without any relations, especially in terms of sentiment analysis. Then we compared our result with ACOS and ABSA quad models in order to compare the F1 score of the ASQP task, which stands for Aspect Sentiment Quad Prediction. Unlike the previous results, it shows a significant improvement in the F1 score. This confirms that adding relation between elements yields a significant improvement in the overall ASQP task. Also, it is notable that the Grove model, which is much lighter in its size, showed better performance than the T5 model. Finally, we tested how our model works in addressing implicit aspect problem. However, the only data we had to compare the results of implicit aspect was ACOS Restaurant 15 dataset. This result showed significantly better results, but since there is only one baseline model, more testing should be done to make a decisive conclusion. This is the basic summary of our results. First, unlike our expectations, adding category in the relation had minimal effect in the F1 score of each element. Still, it showed better performance in the overall ASQP tasks and showed that our model can work better in dealing with the implicit aspect problem. One of the limitations of our study is that the dataset is too small and is unbalanced to predict the category term. Almost 80% of the category data belonged to food quality, restaurant general, or service general category. This dataset is not reliable enough to make an accurate prediction. Future work should be done to test our model with actual review data. Applying it to more recent Amazon product reviews or PEMIN would be important to validify the importance of our model. Also, work should be done to extract various elements like degree of sentiment. This will work to help customers to better understand the given reviews or filter the reviews they want to see. This is the references we use for our presentation, and thank you for listening to our presentation.